Hi, everybody, and welcome to our next Excel video for statistics. So in this one, I want to go through some popular Excel formulas that we use when finding confidence intervals. And this video is going to focus on finding confidence intervals for means. So what we've seen in class are basically two styles. So one style uses the normal curve, or the Z distribution, which I have on the left of the screen. And then the other style uses the T distribution instead. So again, we're finding confidence intervals for means here. So that's our main focus in class right now. Um, so you have the same background requirement check, right? So they both have to have basically good data to start, right? We want a nice random sample. You either have to have a sample size of at least 30, or you need to know that your population is normal. So on the right here, I just have a very quick example set up. So we're going to just pretend we have a sample with size 45. So that requirement check would be met, and we'll assume that it was collected in a good way. We have good random data. Now, how do you know when to use either distribution? So we use the normal or Z distribution in this case if our population standard deviation is known. So that would be the symbol sigma. So when you know that, we can use the Z values. If you do not know the population standard deviation, so you only have sample data, then you would be using the T distribution instead. So there's a few things to do in Excel. Again, this video is not going to focus on going through an entire example. We are covering those in class, or you can watch those in other videos. But the goal here is to show you the Excel steps that you may want to use. So one thing you may need to find would be the critical Z or the critical T value. So for the critical Z value, the formula we use is norm inverse. And for the critical T, it's T inverse. So you can see they're pretty similar. In both cases, you have to give the area to the left. For the norm inverse, you would then give the mean and standard deviation. And then for T inverse, you would actually give the sample size, the degrees of freedom, which uses the sample size instead. Now, I'm going to do an example and pretend we're looking for a 90% confidence interval. So what happens there, you would have 90% in the middle of your graph. And again, we're doing a standard confidence interval that's centered in the middle. And to get to 100%, we would have 10% left over. So that 10% is called your alpha. So the 90 and the 10 is equal to 100. That's how we figure out the two parts. So our alpha would be 10% here. Now, some problems ask for the alpha, and that would be fine. But for finding the critical values, they don't ask for the alpha. They want just the area to the left. So what happens is that alpha, or that leftover piece, gets split into both tails of the graph. So in this case, if we have 10% left over, you would have 5% on the left and then 5% on the right. So to find the critical values, we're not going to use the full 10, we're going to use half of that. So we would use the 5%, or in this case, 0.05. So let's find the critical T. So in the first set, I'm going to pretend like the standard deviation is the population value. So pretend this is population data. What I would do here is I'd start by hitting enter. I'm going to write norm dot inverse and make sure I click the right one here. Again, there's different versions, so you just want plain norm inverse. The area to the left, or the probability, is 0.05. Now, for the normal curve here, again, we're doing a Z value. That's what we're looking for, a critical Z. So the mean is going to be 0, and the standard deviation is 1. They don't want the actual values from the data. They want the 0, 1, because you're getting a Z value instead. And we go ahead and hit enter. Now, you do always get the negative version here. Our formulas do require the positive version, but you would just take the same value and just make it positive. And of course, you can round to the appropriate number of decimal places, either 2 or 3. If this happened to be sample data instead, you would do something very similar. So I would start typing T inverse instead. I would still give the area to the left, so 0.05. And then what happens here is you need your degrees of freedom. Now, degrees of freedom, again, for this material, is going to be your sample size minus 1. That formula does change for different examples, but for our purposes, it's going to always be n minus 1, so sample size minus 1. So we would type in 44 here, and then we can go ahead and hit enter, and we would get the critical T value. Again, they're going to give you the negative version, so you can just use the positive in your formula. So one more time, if you have population data, right, if you have population standard deviation, you're going to use the normal one. So we type in 0.05 and then always 0 and 1. And if you have sample data, you're going to use the T version. you still type in 0.05, but the other information you give would be the sample size -1, so 44 here. Now, in most cases, you actually probably won't need to find the critical Z or critical T. The reason we do that is so we can actually find the error and then create the confidence interval. Some questions you may have to find these, so it's good to know how to do it. But for most cases, if you're just finding the confidence interval, you're probably going to go right to finding the error. And that will get you, again, just a little bit closer to the answer that you're looking for, and you can skip some steps. So Excel basically will do all the work in the background for you with the critical Z and T stuff, and it will just spit out the error, which is typically what we're looking for. So same idea. If your data is population data for the standard deviation, then you're going to be using the normal curve. But if it was sample data, you would use the T distribution instead. But you can see the formula is like almost identical, right? Confidence.norm versus confidence.t. And they actually are exactly the same here. So alpha in decimal form, standard deviation n. Alpha in decimal form, standard deviation n. Now this standard deviation is the actual one from the data. It's not like, the 0, 1 idea we just did. So this actually is the data values that you have. So on the left here, again, I'm just going to demonstrate how to use it. So I hit confidence.norm. You need the alpha value. So this is a little bit different. It's not the area on the left. It's just the entire alpha. So it's much easier to use this. So you don't have to think about splitting that value. You would just use the 0.10 here. The standard deviation in this case is 2.3. And then the sample size is 45. I would close that and hit enter. And the answer I'm getting here is the error. So that would be the error that we would then add or subtract with the mean. If instead you were doing sample data, we can do confidence.t instead. The alpha, here's 0.10. Our standard deviation, again, let's pretend this was sample data, is 2.3, and then our sample size here is 45. Again, notice it's a sample size now, not degrees of freedom. So the two formulas are very, very different going from, vertically, from the critical values to the error. And then here our error is about 0.576. So those are the main formulas that you're going to be using for confidence interval for the means. Again, so confidence intervals, and again, for us, we're specifically focusing on means or averages here. So how to find a confidence interval for an average or for a mean. These are the two forms that you're going to use. And again, it's just going to depend on that standard deviation. If it's population, then you go this way. And if it's sample, you go this way. And you can see the answers are pretty similar. They are very close distributions, the normal and the T distribution. So they're both bell-shaped, they're both symmetric, but they are slightly different, but they're very close. So you do see a lot of similarities. One last thing to keep in mind again, for most cases, you probably will not need to find the critical Z or critical T. If the question just wants the confidence interval, then you can go right to the error. We get the error and we add and subtract it with the mean. So that is typically the fastest way that you can find that confidence interval.